Hello and welcome back to Compiler Programming. Today I wanted to switch gears a bit because despite the name of the language, which is MEAS, which stands for Meta Assembly, there isn't much meta going on right now in the code. And by meta I mean metaprogramming and the ability to execute some code during the compilation of the program itself. And over time, I want more and more of the compilation to be part of that meta execution rather than something that is hard-coded in the compiler. But we do need to start somewhere, and the goal for today would be to have a function that calls another function at compile time, and then it uses this return value as a constant that we can use somewhere else. So let's make that happen. Let's create a new MEAS file. I will call it compile time. Compile time. Let's open it up. We can clean out a bunch of stuff. It's not interesting. Main, we will, I guess, keep. And then we have this function here that will be the answer. It will return us an S32, which I think what exit process wants. Actually, now that I think about it, I do need to actually keep the exit process definition, and maybe it's one of the next things we'll do is allow to more easier import those definitions, but that's not for today. So we have this stuff, we have exit process, it's defined, it does need S32 as a status code, and we will say return, or we can actually do it even easier, we could just say 42, right? So this should work just fine if I run it through the compiler right now. So let's try that out. Actually, we need to call this. So we say build MEAS ---- run, and we say fixtures and compile time. And I actually don't know how to get error status code in PowerShell, so that's something I guess I need to look up. I'll try to use the bash one, but I don't think that will work. Okay, let's try it out and see in Google how to make that happen. I recently switched out from using the standard command line to using PowerShell with this Starship prompt that is a very nice cross-platform prompt written in Rust. So this thing, Starship prompt. If you haven't seen it, it's really nice. It's very fast, and it's pretty cool. Okay, what I wanted to find is PowerShell print status. Firefox really wants me to learn my German. Status code, exit code, last exit code. Okay. So let's try again. And we say, okay, cool. So that works, but obviously that is not compile time evaluation, that is runtime, right? At runtime, we are calling this function and we are returning the value. What I want to do is make that call happen at compile time. And I don't have a very good plan about how this is gonna work, but we're just gonna dive right in. So we need to choose a symbol that will tell us that this thing now needs to be at compile time. I think I like at, and my idea is that basically you would have at followed by some kind of braces. It can be curly or it can be round braces. For now, I think round braces might be easier to implement right now. It is also might be good in later stages to allow it without the braces, right? But for now, I'll just require them and add spaces here so it's easier to see what's going on. So we have this would stand for I want to execute this during compilation, right? And I deliberately don't want a long keyword here because I said I want a lot of stuff to be compile time, and it's just nice if it is easy to use. Anyhow, so now if I try to run this, it will explode pretty spectacularly because it doesn't know anything about that. Actually, surprisingly, okay, I should save my file. Yeah, okay, no machine overload found, makes sense. So I think what happened is it tried to look up this thing, and it couldn't find what it is. So first of all, let's put it inside the tests so we don't have to run it from command line every time, or rather we will run it with all the other tests. And it is fixtures compile time. We will get the main value, main value, void to void, and basically we just actually we might have to do this test somehow differently. This is something I haven't figured out yet, how to make it nice to run tests that actually need to, for example, do call exit process or stuff like this. That is a very interesting question. I guess what we will do is we will have another thing that will be called proxy here, and proxy will just do s32, and it will return this. Or maybe even like this. Yeah, actually let's make it let's change the test to be like this. Right now we don't have, I think, particular tests that check that the constants are actually constant, but it's definitely something that we will add soonish, if not today. And then this would be a very good test, because if this is a constant value, then whatever on the right side needs to be constant, and unless it is compile time execution, this thing fail. So that's something to consider. And it also should allow us to actually test this stuff, right? The only trouble with this approach right now would be that this is not lazy. So the only lazy thing that we have are functions. And that means that if I put this over here, it will stop working. But for now, I think that's okay. The laziness of all definitions is something that we will need to tackle separately. So for now, that's fine. Anyhow, getting back here, I want to look up Now status code. Then I want to check that main value descriptor type is descriptor type integer. And I also want to check that the operand type is operand type immediate 32, right? Program JIT, no, we don't need to do that. We don't need to do any of that. The only thing we need to do is we need to check that, or let's call it status, operand immediate 32 is 42. So that is what we want to check. Now we can run the tests, and obviously it even crashes, but that's fine. We can start working on this. So how will it work? Well, let's search for the constant definition. So this is a constant definition. We check that we have an ID on the left hand side, and then on the right hand side we have this constant expression. Okay. Yeah, this is what I mentioned about lazy function definitions, and I think let's add it right now. Say to do turn all constant definitions into lazy scope definitions. And this is like we can't make regular variable definitions lazy because then it will mess up with the ordering of things. But for constants, the ordering should not matter. Like unless your meta program will rely on order, but in general, I think that meta programs should be written that way that they will not depend on order. And I might be able to provide features to help with that. But anyhow, for constants, my expectation is that it doesn't matter in which order you resolve them or if you don't resolve them at all. So this is something that we need to do. Okay. So here we rewrite the expression. This is also, I think, incorrect. Okay, that we can clean up that later. For now, what we're interested in is token rewrite constant expression, and it clears new lines, rewrites negative literals, and rewrites external imports. Then it's a struct definition, function, and constant sub-expression. And constant sub-expression is just parenthesized the same thing, basically. Okay. Here we need to add some more stuff. Struct definition or function definition or this stuff. Yeah, this definitely will need more work, but for now we'll just say that it also can be token rewrite compile time execution. Yep. We can probably copy this stuff. So token match add, that would be token type operator. I think as far as operator goes, there should be a better way to do it, but maybe not. Token match. Yeah, there is token match operator. So this is like this, right? And actually, we do need to match parenthesized expression afterwards. So this is this. And here comes the main problem or main part of all of this, right? We need to I'm not even sure how to organize this the best. So on one hand, we need to compile that code in isolation, right? So whatever goes in here is not part of what will be the end program. On the other hand, this program does need to have access to our current scope and all the other state inside of the compilation. So it is I'm not exactly sure what is the best way to handle this kind of stuff. I think what I will do for now is I will essentially clone everything, although that is gonna be a bit slow long term, but it might be able to help us for now. Okay, token match state, substate, parent children, token write constant expression. No, this is not what we are doing. And here it's actually 2. It will be a result token. And the main question is what goes in here? What are we doing? Well, we will definitely need to compile these somehow into a GDIT program. So let's go and look as to how this looks like. Program. No, I think it's in value C. Program JIT. So let's look again at what this does. We load the libraries. Then we are doing the compilation of all this stuff. This is actually not necessary anymore. This is already a bucket buffer. I'm not actually sure. I think I don't want to do that anymore. So if we don't destroy the original buffer, then yes, we will be slow by doing this multiple times, but at the same time, this should allow us to work. So let's remove this, and I will add like to do consider. Actually, no, we just don't need it, honestly. The only time we would need to free up this memory is when we get to like incremental updates for cheat, and this is going to be so long from now that this is going to be next year's Dmitri's problem. So for now this is just out. And what should allow us to do is to say something along the lines of the following: program so first of all, let's rename this function. Program compile time, or maybe I want to call it eval. Eval is star builder program. So we are just copying all the stuff that we have. We will create a new nested scope. So we'll say eval global scope is scope make of eval global scope. Good. Now we can do program JIT of eval. Actually, no, not yet. Yeah, we definitely will need to turn this stuff into lazy for constant definitions, because right now it will be flaky, because we're calling this immediately, and that means that we are not waiting for any of the dependencies. But if we turn the other thing into the lazy, then at the point where we need this inside the compilation, we will be resolving everything. So it should be fine long term, but it should be fine now because because of the order here, right? So we never try to reference something that is below us. Okay, so we have program well. Let me open value.h to see what is inside program, so I can check what else needs to be reset or changed. Okay, data buffer, fixed buffer, import libraries, that's fine. Entry point. I think it doesn't matter. Functions, codebase array, database array, global scope, errors, is taken mining progress. Okay, I don't think I need to do anything in particular. It might be better to copy only parts of this stuff instead of copying the whole object. So let's do that actually right away, because maybe it is better to be explicit. So what are we gonna copy? Well, we are going to take this definition and just figure out what needs to happen. So mainly we're interested in data buffer, and we need to say that data buffer is a builder program data buffer. JIT buffer should be 0. Import libraries, yes, we need to copy them as well. And we might want to clone them. Yes, we might want to clone them. So we would say dynamic array. I don't remember if it's clone or copy. Maybe it's copy. And then I would say array import libraries. Oops. Okay, sorry about that. I accidentally put my computer to sleep. Okay, let's close this stuff. Are we still recording? Yeah, we are. Good. Okay. We were left with import libraries. Entry point 0 functions. Yes, we need to also copy all the functions. And this is where we might have issues with different scopes and compilations. This is going to be fun long term, but I think for now it will work for the tests that we are making. If we need to work it on other things, we'll make it work on other things. Nothing of that. Errors, I guess we will create a new one. Array make array parse error. Global scope is like this, right? We need to create a new scope out of previous one. Builder program global scope. And we are not unwinding the stack at the moment. Okay. So that's fine. And then here is something interesting. So we also will need to create a function builder. Function builder eval program and eval builder. The same thing. Let's go to function begin and see what we need to put into this builder. Maybe I should just call function begin, to be honest. No, not really, because do I care about volatility of the registers? I guess maybe yes, because I will call this function from somewhere else. Okay, result. What are you doing to result? Are you even using this thing? Yeah, you are. I don't think we need this. Okay, I don't want to touch it for now. We will get back to this. Import libraries and yeah, that's fine. Okay, so we say function star eval builder is so value star result is function begin of dummy. Actually, if it is dummy, I can just do this. And we need to pass our eval program. Okay. That doesn't work. Okay. Value star dummy. Actually, no, it will work like this. Yes. Okay. So we have a builder that is attached now to this eval program. And that also means that we should be able to do match expression. Token match expression. Right? So it will get the eval program, state, it will get the substate, scope, it will get the eval program global scope, it will get eval builder, and then value star result value is we sort of don't care, I think, or we do. Let me think about that. Yeah, we do. We do. Let me quickly think about how I want to handle this stuff. So essentially, what I want to do is I want to turn this into this, right? Except that I don't have to provide the return value. So I need to take the code. I need to figure out what would be the return type of this thing, and this actually will allow me to do that. I think before we sort of dive too deep into this, we should check if all of this works. And for now, just to make it not angry at us, I will do the following. I will say result token, yes. And token value make, right? This is how I do it. Yeah, so it needs to get a token and needs to get the result. Okay, token value make, we will put you at parent, and I will do value from S64 of 0, so the test actually doesn't match. Okay, let's try to run the tests. Obviously it will not even close to work, and it even explodes. So let's start with the exploding. We will go to, no, actually, yeah. We go dev env mass solution and start looking at that. Let's see what is going on. builder, value descriptor. So it's unhappy about the return. Uh-huh. I think I know what's going on. Yeah. So we create this builder, but then this builder does not have a return value. So it's everything else is very unhappy about that. I guess what I want to do is, well, let's actually check what we get here as a result value. I'm quite interested in that. Result value, uh, that is very interesting. Descriptor, descriptor type integer. Okay, so it got the right answer, but so what's going on right now is that we seem to be correctly evaluating this thing, but when we return from a function, we immediately shove this thing into a stack location so that we don't have problems with arrayx register where things are returned. And that might be problematic for us, I guess, or it might not be. I need to think about that. I guess we can start by just creating a. Well, for now, let's just do this. Eval builder descriptor function returns result value. Let's try it that way and see if we can get further into the stuff. Okay, now we have an issue that, okay, I know what's going on. Now I need to also do function end of eval builder. Okay, we exited with status code 1 because the return type, sorry, the value did not match and the operand type did not match. Okay, all of that is fine. Although, why didn't operand type not match? Okay. Because I'm doing value from S64 and value from S64 tries to automatically find the right thing. Value from S32 is what I want. Yeah, for now, let's just do it this way. Okay, good. This is what I would expect. Now, we were able to make this thing and even compile it into a separate JIT program. I said all of this is super inefficient. Like right now, we will do the whole compilation of the whole thing every time we come across this add thing. So like this is definitely not how it can survive for long term, but it will get us through for today. All we need to do now, really, I think, is to uh, take one of these. Actually, one of these. I wonder if we need to do scope lookup force. No, no, we shouldn't need to. Oh, this is gonna be fun. So if we want to call something from C, we need to know what will be the return type of that thing. Yuck. This is all I have to say. So here's the issue, right? This thing can call arbitrary code at compile time. That arbitrary code at compile time can return arbitrary values. But according to C calling convention, we need to know what is at least the size of that value and what is its type so that we can correctly interpret it and correctly comply with the calling convention. So I think long term, what should happen here is that eval builder should wrap the return value into a value struct so that we have consistent return type here. And so if inside of this builder we add some instructions that would take this 42 and essentially turn it into like a value thing, then we in here we always will get back the value. We will unwrap that value and stuff it into status code, but this will require a bunch of changes, I think, and a bunch of testing, and I don't want to go into this today. Today I'll just assume that whatever we call it compile time is going to be S32, and that's basically it. Okay, so we have void to S32. Code, did code, value as function. I will need to do eval builder value. Actually, we could have gotten it from here, but doesn't matter. Yeah, I think I will get rid of this stuff. I don't think it's very nice. Yeah, so for now, this is what it's gonna be. This is obviously not great. Value as function, I guess, wants to have a program, and because it's a macro. Yeah. eval program. Can I just do this? No, I have to cast it. Cheated code, cheated code. Okay. Well, let's see how we are doing. I think it should just work now. Apparently not. Okay. Where are you crashing? Access violation executing location. Great. Well, let's try to understand what's going on. So JIT code is somewhere, and it looks like it's a reasonable location, I think. Eval builder value. So let's inspect what is inside the value. We have function, we have operand. Everything seems to be on up and up. We have a function. It doesn't have any arguments. We have operand, which is a label. Yeah, it points somewhere into this stuff. So all of that seems fine. Let me separate it like this and say S32 immediate is like this. It just allows us to easier step into the assembly. Go inside, go into assembly. So first of all, the question is, can we even step in there? We can. So we just does this. Can we step into here? No, we were not able to. Okay, so first of all, this is wrong. Lazy function definition. So first of all, what's wrong is that the return type of this is screwed up. Yeah, I need to do this stuff. Function return descriptor. Function return descriptor, yes. In here, instead of this stuff, I need to say this. Result value descriptor, and here it will be eval builder descriptor function. Okay, let's see if that is better. Step inside. Did I rebuild it? Uh-huh. I'm not I'm not using the parse block thing. So which means that the implicit return does not work. Okay, parse block. How do you work? Uh-huh. I guess the easiest thing for us would be to just say move value here. So move value eval builder function returns location. We don't have one, sadly. Actually, we kind of do. We can use parent location. Location eval builder returns. Let's extract it. Value star return value. Um, eval return and result value. Let's call it expression result value. Okay, so now inside of assembly, oh, too many breakpoints. We should see the right thing to be returned. Yeah, okay. These two instructions are technically useless because we are taking something from EX, putting it into stack, and then putting it from stack to EX back, but that's optimization part, and that's not what I care about. I don't understand this. Why can't it step inside of this thing? So it doesn't crash, but it also does not want to go there. Wait. What? This is really wrong. So it calls itself? What? This doesn't make any sense. So this address is this address. Yeah, I can imagine that now it's in ends up in a very weird place. The question is, why does it end up like that? So it seems to me that somehow we end up not compiling the second function, or labels get screwed up somehow. because this is outer function, or not, like this is this part. The question is, why is this not compiled into a function? And I don't understand that. I guess we need to look into here and see what's going on. So we go inside match expression. Let's go inside here. Actually, rewrite expression, token rewrite function calls. Yes, this is what I'm interested in. We should find a function call in here. We did. Let's recheck that our program is what we think it is, and our builder as well. Program, everything is zeros. We have a functions thing. It has one function. So everything seems to be okay for now. So let's go into force value. We should find ID. Damn it. I should have stepped inside of this thing. Well, since I didn't, we did find a function. The function has the right things I would expect function to have. Okay, arguments, data. It has no arguments, but it should have a return type, which is register A. Everything seems to be fine here. What is a result value? Result value is any, so it will just move it like this. Result value is now a function, it's a label. Everything seems fine. I don't particularly care about arguments. There are none. It is a function. So this is also fine. Here we have any as a result value, which is not even used, I guess. Yeah. Could it be that is the issue? That we actually end up having some error somewhere? Call function value array. So everything is fine. We are doing our saving of registers. Let's just run till here. The return size should be 4. It is. Everything is fine. Okay, so we have a label label. It might be that we didn't copy enough stuff. So to call operand is label 32, and it is this stuff. Let me just put it here. Okay, so it encoded the call. Now it encodes the move. So we got the value here. Yeah, all of this seems perfectly fine to me. Eval return. This is also fine. What does function end do? It just aligns, that's fine. So the question is, do we have two functions? Inside the eval program, we now should have two functions. And we do not. We only have one. Interesting. Who pushes a function into that array? I thought it was function begin that does that. No. Function begin. Da-da-da. Yeah. Function begin pushes this into there. Did I pass in the wrong thing? No, we are putting it into eval programs. So wait a second. Let's go to here. Do you have any functions right now? You do not. Builder program functions. You also don't have any functions. I think I understand what's going on. So if you go into force lazy function definition, yeah, okay. So what's going on is that when we copy the functions, they still point back to the old program. And that's not cool. So we would have to remove all the usages of this stuff from our code, right? That program needs to be passed always explicitly now and never getting from the builder. Okay, let's make that happen, I guess. Program star program and see what breaks. I think a lot will, but I guess that's what we have to do. Invoking force value. Program star program. Scope lookup force. Everybody will need now a program. 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 Okay. Do you have a program? No, you don't. Can I somehow make it better? I could go through all the builders now. That's gonna be terrible. So we'll need to also change how we do this stuff. Yeah. Token rewrite statement. We'll now need to accept. So you're gonna accept now a program. And you're gonna pass a program to everybody. It's gonna be a lot of stuff. Maybe I want to bundle up all the things here into like a special parse state object or something. I don't know what would be the good thing here, but I don't want to think about that right now. Token rewrite constant expression is unhappy because what? Okay. Token rewrite statement. Now we have clear new lines that does not accept this stuff. Like this. Like this. Program, program, program for everybody. Okay, you also need to get a program. And you too. This is a bit unfortunate. I know it's not the most exciting programming stuff right now, but sometimes that's just what happens. And it's really, I really wish there was a good way to say, and now I want to propagate all of this stuff. Compatible types from program start to token matcher state. So I guess token rewrite expression is also unhappy about us. Well, let's just do the first pass. and then continue with the second one later. Okay, program. I could have probably do some horrible hack there, but honestly, the only reason that program is on the builder in the first place is exactly because I didn't want to do this refactoring I'm doing right now. So I guess, karma caught up to me and now I have to do it. And I also have a program on the builder. So, sometimes it is, if you do a hack, you need to be ready to actually do the work later. And go through this pane. Okay, we are getting somewhere. What do we have left? Okay, token rewrite external imports. Did not have a program. Well, we can do that. What else? Token rewrite expression. Array index. Okay, so token rewrite expression. Token rewrite expression. You also will need a program, and this will generate a bunch of new errors. Okay. I wonder why this one didn't happen before. Okay, token match statement needs to be updated. Okay. Program, star program. Okay, you also need one. And now I need to update parse block. Do we have like source.h or something? Okay, we do. Yeah. We might need to clean up builder program somewhere. So some stuff like this, yeah, there is definitely needs to be a check. So who does this? You do. No. Who else does this? You do. Definition and assignment statements. Yeah. You will get the program explicitly. You already get the program explicitly. Same for you. You. Yeah, it's actually a very good refactoring. It's just unfortunate that I have to do it on the video. Yeah, looks like we use program a lot and we were always getting it out of the builder, and that's not necessarily correct. I think I will want to remove it from there at all, but it might get more things to refactor, so I will not do it right now. Although I will add it here. And where is our function builder? Function builder. Where are you hiding? Fix me. Remove this reference. Okay. Okay. Looks like we are done with builder program. Now we just need to remove all other things. Program. Okay, I assume you want this. You also want your piece of the program. You get a program and you get a program. Everybody gets a program. Okay, I think we are finally getting there. But let's see. Maybe not. Because this will generate a bunch of warnings for us. And good. Who is next? Match fixed array type. So apparently you have a definition. It's fine. We can give you the definition. Good. Okay. Just a little bit more. Okay. Now, scope lookup force now needs a program. Okay, we can do that. There is a macro where I need to shove it in now. Okay, that's quite easy. Couple more. Okay, almost there. Program entry point. Program. Okay, good. This is done. What I want to do now is I want to find our test, disable it, and try to run the tests. Hopefully everything should still work. It does. Okay, that's good. we can re-enable our test back up. And now we should get our builder in the right place. So let's check that. Um, I didn't reveal this stuff. Okay. So the big question now, do we have two functions inside of here? We do. That is great. Can we still do this again? And now let's look at disassembly again. Okay, we'll step inside. And now it's much better because as you can see now this address is actually pointing us to this, which is the right function, which will return us 42. So it might actually be that we have succeeded in doing this. So we jump to here, we return 42, we return, we do a useless move, we restore the stack, we return, and if we go back to this view and we step away from immediate and we look at immediate, it is 42. So I think this is all that we needed to do for this to work. Obviously, as you saw, there is plenty of stuff to fix afterwards, but for now, I think if I press F5, we have zero status code. So if we run the tests here, we will actually see them succeed. And to just be 100% sure that everything is indeed working, what I will do is I will make the test fail again and then make it pass again. Great. Okay, that was a good video, I think. And now we can actually run stuff. We can even do funny things, I think. I'm not sure if it will work. If it doesn't, then I will not look into this, but I can probably do this stuff. So I can do -2 plus, and this should still work, but we'll see. Okay, there is some issue somewhere, but that's not important. I guess this way should work. No, there is still a problem. I think that the problem is with the size of the immediates, and that's something I definitely need to fix. Yeah, okay, so the problem was the size of immediate. But it's nice. So technically we can put arbitrary expression here now. It will take the snapshot of the program at the point where we are doing this. It will execute this stuff and then return, and everything is great. There is plenty of things to fix, but all of that will happen later. For now, thank you very much for watching, and hopefully see you next time.